skills, but it's mostly reliable. It's also nice to me, like, when comparing it to, like, for example, the alternating series, which is just like a lot more writing. The ratio test, to me, feels like a better test to do because there usually is something you have to calculate and show. Before we jump straight into the ratio test, it does have some prereq skills that we want to basically review. And the types of prereq skills that we have are basically going to be things dealing with limits, things dealing with factorials, and then things dealing with exponents. And my OneNote is frozen, so I get an X out of it and try it again. All right, let me try this again. So first limit, again, we should be able to do these pretty quickly. N is going to go to infinity. We are still kind of going to be talking about series. What will be the limit of that expression? 1/2. So like, it's basically what matters most. So we have the square root of n over the square root of 4n. Looking at what matters most, the square root of 4 is going to give you 1/2. Easy enough. Another limit one type of example we see often with the ratio tests might be something like this. N is going to infinity. So what will we say the limit of that expression is going to be? 0. So again, you could FOIL it, but again, hopefully you can kind of see that if you do this, you're going to have like a 2n squared. So it is heavier on the bottom. So we know automatically it's going to be 0 without taking the time to FOIL it together. Other prereq skills we have, so we have limit prereq skills. We also have some prereq skills dealing with exponents that we do want to be able to kind of simplify fairly easily. If I have 3 to the n plus 1 divided by 3 to the n, what is that going to reduce to? Just 3. Two ways to do it. You can either say, hey, those are the same base. So we know the same base, when you're dividing, you can subtract the exponents, which would give you just 3. The other way to do it is you could split up the 1 in the numerator. And you're still going to, of course, get 3. But again, that would be something that I would expect you to do fairly quickly. Try that one for me. Looks a little bit stranger. But see what you can figure out what that one would end up simplifying to. And again, two ways to kind of think about it, like properties of exponents. Main one though here, same base with the division, you know you're going to subtract the exponents. What are we saying that is going to end up simplifying to? Say it again. E cubed. So again, you're doing top minus the bottom. The 3 n's cancel. That 3 is left over, and the negative 5 cancel. So E cubed is what we get for that one. The last prereq skill that we're going to look at is going to be factorials. This test that we're doing today is super important when we are dealing with factorials. It tends to be like the best option that we have when we are dealing with factorials. I think most of us know what a factorial means. You start at that number, count down by 1, multiplying until you get to 1. So like 4 factorial, 4 times 3 times 2 times 1, 12 times 2, 24. 3 factorial is 3 times 2 times 1, which is just 6. 2 factorial, 2 times 1 times 2. 1 factorial, which is just 1. Anyone remember what 0 factorial is always going to be? 0. It's 1. The reason why it's 1, and probably why the easiest way I can kind of say that it's 1, is if you're looking at your factorials, like 4 factorial is 6. Divide by 4, divide by 3, divide by 2, and then divide by 1. So we just define 0 factorial as 1. If I just want to write this as an expression, since we often will be dealing with this as a series, the way I think about just n factorial in general will be like starting at n You keep subtracting 1 for as ever long as you need to until you get down to 1. But we know we're just basically be dropping it down by 1 and then all the way to 1. I kind of use those ellipses to fill in the blanks. Yes, Seth?
Can you take a factorial of a negative number?
Factorials, we will only do of positive integers. So like 3.5 factorials, not a thing. If you type in the calculator, your calculator finds an answer, but it's not a thing. It's more of just an issue with the program in the calculator. When will we often see factorials? Often we need to be able to simplify factorials fairly easily and fairly quickly. So looking at this one, if I have n plus 1 factorial over n factorial, what is that going to simplify to? Just n plus 1. So like how I'm thinking about this one, n plus 1 factorial, if you were to start that one off, like that's the first number you would use. What number are you going to multiply after that one? N, and then after that will be n minus 1, n minus 2. But I can just stop at n and say, hey, that's just n factorial over n factorial, which is just n plus 1. If it helps you convince it, like I can kind of make up something like 8 factorial over 7 factorial is just going to give you what? 8. And again, that makes sense because 8 factorial is the same as saying 8 times 7 factorial over 7 factorial, which is just 8. So if you want to be able to simplify factorials, try this one for me. So you can figure out what that would simplify to. So I'm looking at this one, I'd probably simplify that when we see in the numerator. That's going to become 2n plus 2 plus 3, or 2n plus 5 factorial. Again, that is representing a number. So if I'm doing my factorials, dropping it down by 1 each time, all the way down to 1 would be the factorial. I kind of pause it once I hit 2n plus 3 factorial. That's going to cancel out with the 2n plus 3 factorial. What is left over? Just 2n plus 5 times 2n plus not 5, but plus 4. Questions on simplifying factorials? All right, so let's go ahead and look at the ratio test. Again, it is one of the ones that I like using because I think it's like you can be very confident in your work in it and kind of how you answer it and justify it. It is called the ratio test. The main clue that we're going to use the ratio test is, for now, is if you're dealing with a factorial. We will also, in the second half of the unit, use the ratio test a whole lot if we're doing something called a power series. We don't know what that is yet, but it is going to be a case where we use the ratio test often. Also, we're going to use the ratio test a lot if like nothing else works. Like we can't do the integral of it, maybe there's not an easier series to compare it to for a comparison test. There's just like no other rule that works. So we want to try something. Let's try the ratio test.
We don't know what a power series is.
We know what a P series is, but not a power series forming a polynomial. I should be more clear.
What is that?
Exactly, we don't know what it is yet. So for a ratio test, the expression that we're going to be finding is going to be the limit as n goes to infinity of the absolute value, and that is important, of a sub n plus 1 over a sub n. And that is a statement you want to write down whenever you're doing the ratio test. Do be careful, this is not the limit comparison test. So for the limit comparison test, we compared a simple series to the one that was given. This one we're comparing a sub n, which is just like a term. A sub n plus 1 is like the next term. So we're basically comparing two terms that are side by side. Your limit can be equal to three things. Your limit can be less than 1, it can be greater than 1, or it can be equals to 1. If it's equal to 1, that is going to go ahead and be the one that will just say it's no info, you're going to try something else. If it's less than 1, what do you think that series is doing? It's converging. If it's greater than 1, that ratio is greater than 1, then it's going to be a diverging series by the ratio test. We're not going to also abbreviate this one since there are other tests that have an R in them, like the root test. Even though we don't need to learn it, we don't want to confuse it with that one. So we will always kind of spell out the ratio test. So I just have 2 examples for the ratio test because it does tend to be pretty straightforward once students kind of see it worked out. I'm going to kind of color code my work. So I'm going to do everything that is required to show in blue, everything that is optional to show in red. So you can kind of see like what the full steps look like, and then as you get better at it, what you're allowed to kind of skip over. So let's first talk, like it does tell us to use the ratio test examples. Looking at this first one though, what might be some clues to us that a ratio test would be a good idea to start off using? There is exponential, but it's kind of like combining an exponential with like a polynomial. So we have like an n squared and an exponential. Can't really find a simpler series to compare this to. Like it's not really like a more complex geometric one. There's just like a lot of stuff going on. So like when I see a lot of stuff, ratio test is going to be a good choice to make. What you always have to show when you start off the ratio test problem is you have to write out the limit you are finding. So we're going to go ahead and write out this statement. You want to tell the person grading it that is what you're finding. I'm going to use red for anything that would be optional to show. So you can kind of basically show it if you want to show it. A sub n is just the formula we have. So it's going to be n squared 2 to the n plus 1 all over 3 to the nth. A to the n plus 1 literally means the term after you plugged in n. So basically everywhere we see an n, we're just going to replace it with n plus 1. So I have, instead of n squared, it's n plus 1 squared. Instead of 2 to the n plus 1, it's 2 to the n plus 1 plus 1. Instead of 3 to the n, it's 3 to the n plus 1. And we have absolute value bars around it. Ugly, ugly limit, but we do know how to simplify that. If we're dividing by a fraction, that's the same thing as what? Multiplying by the reciprocal. This next step would also be an optional one to show. But again, I think it helps some students to see it. So I have the numerator, I'm going to change that to an n plus 2, times the reciprocal of the denominator. And then I am going to switch colors, because if you don't want to write down those two in red, you can just jump straight from that initial blue step to this one. And that's where you kind of multiply by the reciprocal and line up things that kind of go together. So like I'm going to line up the n plus 1 squared with the n squared. I'm going to line up the 3n with the 3n plus 1. And I'm going to line up the 2 to the n plus 2 over 2 to the n plus 1. So again, you can jump from first blue step to that next blue step. Next one would also be kind of like an optional one to show, where you're just going to kind of simplify it. This first one I can't really simplify, I can't cancel across those parentheses. That middle fraction I have, 3 to the n over 3 to the n plus 1. Once you simplify that, what are you going to be given? 1/3. So you have like n minus n plus 1. You're going to be left off with a 3 in the denominator. Then that third fraction, after simplifying, what would you be left with? 2. And then we can go ahead and think about the limit. So n is going to infinity. The only limit that we're really having to find is from that first fraction. So I have an n squared over an n squared. What is that limit going to be? a 1. So imagine FOILing out that numerator. It's going to be an n squared. N squared over n squared, what matters most is going to be a 1. That 1/3 is a constant. That 2 is a constant. Switching back to what's required, that limit is equal to 2/3. And then we do want to state why that limit is important. What is 2/3? Less than 1. Since 2/3 is less than 1, what do we know about the series that we're talking about? Series converges by the ratio test. So I'm going to zoom back out so you can kind of see everything. Again, if you can just show the blue steps and get everything correct, that's all you have to show at a minimum. Show what you need to show. Always have to kind of show the setup, and that's something that students often leave off. And so we have to always say what we're trying to find. You can jump straight to multiplying by the reciprocal and lining up everything, but then you do have to clearly state what that limit is equal to, why is important, and then your justification from there. Question on any of those steps? All right, try the second one on your own for me. Before you get started on it, what's your big clue that we're going to use the ratio test for that series? The factorial. Like if you see a factorial, just don't waste your time trying to figure out another test. It's going to be the ratio test. Go ahead and take a moment to try that one on your own. Again, either showing the minimum number of steps or a little bit more if you just want to make sure things are lining up correctly. Again, a big idea with this test is going to be just making sure you can kind of simplify factorial expressions, exponent expressions, and things like that. The ratio test is an important one because we will see it fairly often in the second half of this unit with Power and Taylor and Maclaurin series and polynomials. Take a moment to try that one for me. I will say a lot of the tests we use the alternating series test for can also be done using the ratio test. So looking at this one, again, you always want to show that setup. We are finding the limit of a sub n plus 1 over a sub n. I went ahead and skipped those first two steps I did in the other one. So I had the a sub n plus 1 times the reciprocal of a sub n and kind of lined up things correctly. Simplifying it, 2 to the n plus 1 over 2 to the n would just give you 2. And then with the factorials, basically all you have left over is a 2n plus 2 kind of 2n plus 1 in the denominator. Taking your limit, that's going to be the coefficient of 2 times what's going to be the limit of that second fraction, 0, which is going to give you 0. Why is that 0 important? Is less than 1. So we know that the series is going to converge by the ratio test.
Wait, how'd you get 0?
How to get 0? Because that denominator of the second fraction is the only one that has the n's left in it. So we have basically a 1 over like a 4n squared if you do what matters most. So if n is going to infinity, the denominator is getting exceedingly large.
Thank you.
Any other questions on the ratio test? All right, so that's it for the convergence test. There is more we do with the ratio test, but that's going to be kind of like an after quiz situation. The homework I am assigning you is going to be the last homework we have before the quiz. Hopefully you haven't gotten too far behind on the homework. But homework 6 with the ratio test, you have like 16 to 32 multiples of 4. Please skip 28. I will say this last section of the homework, the 52 through the 66 evens, that's going to be a really good practice for the quiz. That basically has all of the convergence tests mixed together, and you'll have to decide kind of what would be the best test to use. So like clearly do all your homework, but that last portion of homework 6 is probably the most important of all the homework assignments because it does mix all the tests together. Other than that, your quiz, is on Friday. Make sure for me, if you haven't already, that you definitely have filled out that form, letting me know and the school know when you plan on taking the AP exam that is due by Friday. But we'll have the quiz this Friday over just the convergence test. Tomorrow is going to be a work day, so I just want you to come to class tomorrow with a whole lot of questions, or just be ready to work and finish all of your homework. There are a lot of things you have this unit to practice with. So like if you finish the homework or if you're looking for stuff to study with, at the end of your notes from this first part, I have like a compare and contrast where I just give you a bunch of series and just like good practice, like look at the series and try to figure out what test you might use to justify its convergence. I have the answer key at the bottom, including like which test I would personally use. Again, it may not be the test you use because there are sometimes many series that have more than one test that works, but I try to mark the ones that I would personally use. Also, if you finish all of the homework, for this unit, there are actually 4 old quizzes for you to look at and practice with. So there's really no excuse in this unit to say there's not enough practice. I think this is probably the most practice I've given for a particular unit. But go ahead and start working on the homework. Again, come with questions tomorrow. So if you get stuck on a homework question, like put a star by it. But basically that's all we're doing tomorrow is it's a work day and a day for you to ask questions and all of that. Other than that, I have nothing else. But feel free to, especially if you're at home, ask any clarifying questions if you have them.